In this video, we're going to be looking at similar shapes. The first thing you should know about similar shapes, it is when we have a smaller shape and a bigger shape, but they are the exact copy of each other. They've just been enlarged by a certain scale factor. So in terms of scale factors, they're very important in this. We have a length scale factor, which is x. So let's say that was 2. So what that would mean is the sides have been multiplied by 2 to get from shape A to get to shape B. The area scale factor, we then take the length scale factor and square it. So if the length scale factor was 2, the area scale factor would be 2 squared, which is 4. So let's say the area of shape A is 2, that means the area of shape B would be 8, because 2 times 4 makes 8. And finally, for the volume scale factor, we take the linear one and we actually cube it this time. So that would be 8 in this situation. So you'll be given different scenarios and you have to apply these to try and work out what the missing values are. So let's have a look at question 1. Find the area of shape B. Now straight away we are told the length of A is 6 and the length of the base in B is 12. And we also know the area of A is 9 centimeters squared. So I think making a little note like this of the scale factors you're going to be using is really useful when it comes to questions like this. So our length scale factor, what have we done to get from the 6 up to our 12? Again, multiple ways you could do this. With this one it isn't too bad because you can just look at it. But 12 divided by 6 equals 2. So they've multiplied by 2 to get from A to B. Now, we know from our rules above, if the length scale factor is 2, the area scale factor is going to be that one squared. So that means our area scale factor is going to be 2 squared, which equals 4. So you're going to be getting 4 times bigger from A to B. So that means we have to take our area of A, multiply it by 4, and that's going to get our area of B, and that is going to be 36 centimeters squared. And that is going to be our final answer. Now let's look at a harder example. This time we're not given any lengths at all. We're just given the surface area and the volume of 2 cuboids. So again, let's let this shape be shape A and this one be shape B. Always identify the one that is common in both. So for example, here we have the surface area of each one. So our area scale factor is going to be 144 divided by 16. Now you can do bus stop, you can do whatever you want. That is going to be 9. Now remember, our area scale factor is our length scale factor squared. So if that equals 9, that means that our length scale factor must be the square root of 9, which is 3. So for example, that would mean if the base of this here was 4, then at a scale factor of 3, this would have to be 12. So that's all that means. So now that we know the length scale factor, we know again from the previous page that to work out the volume scale factor, we have to cube it. If you remember, it was x cubed. So that would be 3 cubed, which is 27. So that means in terms of how much space it takes up, shape B is 27 times bigger than shape A. So we know the volume for shape B. So we need to work out A multiplied by 27 equals 675. Now an easier way of doing that is simply 675 divided by 27. And again, you can sit here and work it out. The answer is going to be 25 centimeters cubed. And that is your final answer. Thank you very much for watching, and I hope that helped.